It's identical to the y equals x, the linear parent function. And if you're looking at the negative values, it is identical to the function y. Let me see if I can write this tiny. The y equals negative x value. That's an x. And then this one is the y equals x. Okay? The reciprocal function. This one is a interesting one. So we're bringing in absolute values. I'm sorry, not absolute. We're bringing in asymptotes. Okay? So when you're graphing this, I want you to do a dashed line down the y-axis to represent an asymptote, and a dashed line down the x-axis. Okay? The reason is because if you're trying to find an x or the y value, let me erase this real quick. Let me show you why there's an asymptote. Okay, if I went ahead and said x equals 0, that would mean y equals 1 over 0. And you all should know, hopefully your Algebra 1, Geometry, and Algebra 2 teachers told y'all this enough, you cannot divide by 0. So this does not exist. Hence, it gives you an asymptote. Okay? And the same goes true for if y was on the bottom, you're trying to solve for x. So there's two asymptotes there. So D and E. Okay, make sure you write down the parent function for the reciprocal function. Okay? Now we're going to do some practice problems. Graphing a piecewise function. This should be funny, seeing as... Okay, so go ahead and write down the equations right here. You don't need to write the whole, unless you want to, the whole exclamation part. But I'm going to go ahead and get started graphing because this is taking me forever to graph it. Okay, so if I'm looking at the first equation, x squared, if x is less than or equal to -1. So that means starting at -1 and getting smaller, I'm going to graph x squared. So I'm going to take -1 and I'm going to square it. That's going to give me +1. So I'm going to graph that point right there. And I'm going to do -2, square that, and it gives me 4. So we've got our first graph, our first part of this piecewise graph. And I know all of y'all graph way better than me. I'm going to do arrows on that. Okay, the next part, and you can't tell here, but I did a dot, and it's a closed circle because x is included. If I look at the second equation, it's open because it's just it's not included. So if x is between -1 and 1, and we're going to use the linear parent function, I'm going to go down to -1, -1, and I'm going to put an open circle. Hopefully you can tell it's an open circle. There. Perfect. And I'm going to go through the origin all the way up to 1, 1. And that does not look like it's going through the origin. Let me try that again. And we'll see if it's worth it, if erasing it. Okay. I'll I'll start here and do my closed circle. And then there. And last but not least, I have the reciprocal function when x is greater than or equal to 1. And this is actually, it starts at 1, 1, so I can go ahead and close that, and I'm going to just draw, and it shouldn't be touching the y-axis, or I'm sorry, the x-axis, because there is an asymptote there. So make sure you draw that on your picture. Like, don't let it cross or touch the x-axis. Okay, so that's how you graph a piecewise function. You break it up. I know it helps me when I was learning how to do this. I would draw like a vertical line so I could break it up visually. I've seen people cover up part of their paper with it just so you can visually see what you're doing. Okay? Now, evaluating piecewise functions, you pretty much solve it the exact same way. Okay? So if we're looking at when f of x is, go ahead and write down the problem, and then we'll solve for these 4. So f of x is, they want us to solve for when it's -5. So -5 is less than 4, so I'm going to use the top equation. So I got 2 times -5 plus 3. I know y'all probably all can do this on your head. I'm just going to write it out to give you guys time to write down. Oh, that looks like an 8. Okay. Plus 3. And that's supposed to be a plus 3, and you should get -7. Okay? All you do with these types of problems is plug in what your x value is. That's a 7. Doesn't look like it, but it is. And you solve. Now, notice f of 20. 20 is not graphed on this equation, so this does not exist either. There's not a graph for it. Okay, last but not least, the 9th parent function looks like this right here. Okay, this is called the greatest integer function. I know I'm running a little long on these notes. I do apologize. So go ahead and write out the greatest integer. Okay. The function is, it's f of x. It kind of looks like an absolute value, but they're brackets. So you got f of x equals the bracket x. And this function's pretty interesting. We won't be using it a whole bunch, but you will see it in calculus. So you need to see this again. So I want you all to get used to seeing it. Okay? And basically all that is saying is it's the greatest integer that is less than or equal to x. Meaning, if I said x was 11.5, your y value would be 11. If I said 4.9, your y value would be 4. Now the negatives, people always mess this up. So it's less than or equal to. So you have to think about a timeline or a number line. If I said negative 2.4, what is less than negative 2.4? It would be -3. So you have to really think about the negatives and what's less than, because people miss that all the time. Okay, so last, I promise we're almost done, about a minute left. We've got some practice problems. So if you're evaluating the greatest integer function, okay, The first one, 0.3. So it is the greatest integer that is less than or equal to x. So this would be 0. And that's a 0. Okay. Negative 4.7. Okay. First thing people think is, oh, it's negative 4. Well, actually, negative 4 is greater than negative 4.7. So think of a number line. What is less than negative 4.7 is negative 5. Okay. Negative 3, well, that is an integer, so the answer is negative 3. 5/4 is really like 1.25, so that is 1. And then f of pi, we all know pi is 3.124, so on and so forth. So the greatest integer less than pi